Kia ora everyone. Today our topic is going to be special power supplies. So what does this mean? If we have a look at the first slide here, we might be able to work it out. What have we got? We've got a UPS here, solar panels, a generator, wind turbines, and a couple of electronic power supplies. So the crux of this unit here, or this topic, is that from time to time we are going to come across power supplies outside of our normal experience. So our normal power supplies will be what? Power coming from the street. That will cover 99.99% of the power that you will come across. And the other tiny percentage that you have to worry about as electricians, probably batteries. Right? We're going to come across stuff that have batteries inside it. But every now and then we're going to see something that's a little bit different. Now, we've covered some of these things before. We've looked at solar panels, or solar generation. We've looked at wind turbines. We've looked at generators, or fossil fuel power generators, whether they're diesel or whatever. And we've looked at those from the point of view of generation. When we talked about generating power in New Zealand in the national grid. But this topic is about what we might see when we're out working. Why is that important? Well, we know we've gotten pretty good at the idea of isolating a power supply when we're working on something, and maybe isolating, an entire house or something while we do some work. But we need to be aware that there's going to be other things from time to time that may provide a second source of power that we need to be aware of. And if we look at all of these, they fall into that category. A UPS, if it's installed in a building and we're going to turn the power off, the UPS is going to try and kick in and provide power. That could be a problem for us. A lot of buildings now have their own solar installations, or even wind turbine installations, which will provide an alternative source of power even if we kill the mains. A generator. Some buildings have their own standby generators for exactly that same reason. And again, if we turn the power off, what's going to happen with that standby generator? And then these electronic power supplies, just alternative forms of power supplies that may provide power that we don't expect, or at different levels than what we expect. Some of these power supplies are pretty clever and can actually provide power at a voltage that is much higher than their input voltage. So we need to be aware of those. So these really safety things, they're mainly awareness. It's about awareness of each of these things, what they do, what they're for. And so we know that if we come across them, we know what we're looking at. I would hate for one of you to get a shock and maybe even die because you killed power to a building that had a UPS, and then went and worked on something and that UPS shocked you because you didn't know what you were looking at. Alright, so let's get into it. What have we got? We're going to start with a UPS. What is a UPS? An uninterruptible power supply, UPS. Or uninterruptible power source is an electrical apparatus that provides emergency power to a load when the input power source or mains power fails. A UPS differs from an auxiliary or emergency power system or standby generator in that it will provide near instantaneous protection from input power interruptions by supplying energy stored in batteries, supercapacitors, or flywheels. The on-battery runtime of most uninterruptible power sources is relatively short, only a few minutes, but sufficient to start a standby power source or properly shut down the protected equipment. Actually, let's talk about these. There's a few points in there that I just want to cover off. So UPS in general, this is not going to provide power to a whole building. It will usually provide power to essential things, usually computer systems, right? So what happens? The power goes off, UPS kicks in, keeps power onto the computers for long enough for us to do something about it. Or if we're lucky, for long enough for us to continue using that thing until our mains power comes back on. It says there it's near instantaneous, right? So it's an electronic apparatus that will it's continuously sensing the power coming in, mains power coming in. So we have it plugged into mains power, and then we have an output which our computers or whatever are plugged into, and they'll just get normal mains power from the mains plug on the UPS. When the power shuts off the UPS, the sensitive electronics in there, notice that very quickly that the power's gone off and quickly switch on batteries, which are contained inside there. There's some other stuff in there like an inverter and that kind of thing, because we need to make sure that that battery voltage, when we change over to battery power, that it's putting out 230 volts AC, right? We need the same power. So that we have an inverter in there and that kind of thing. But the crux of the UPS is that because it can switch so fast that in a lot of cases it will switch over before the computers or whatever else even notice that there was a change, which is pretty neat. So it gives an uninterrupted power supply. If we were using other power supply like a backup generator, for example, well, then you have to go and switch on the generator, or it may have its own auto run circuit, but that's still going to take a few seconds at the very least, probably a couple of minutes in most cases. So you'll get power back on, but it's not going to stop you losing power initially, which can be quite important in the case of sensitive electronics. If you're thinking data and stuff like that, like you think in the modern world, the amount of data that's continuously flowing, what about the machines that the computers that monitor EFTPOS transactions for banks or something? What if you switch that off, like all of those EFTPOS transactions that are happening at that time just suddenly collapse and then people don't get paid or whatever? So UPS is really useful for that sort of thing. As it says there, usually a relatively short period of time. Funny story about that, when I might have told you this before, but on my second tour to East Timor, we had mains supply to our camp, and my job, my most important job on that tour, was to maintain power to our camp. So we had mains power. Now, that's the only time when I've been on an overseas tour of duty that we actually had mains power. But the mains power in Dili, the capital city of East Timor, the mains power is very unreliable. So we would have power cuts every single day for a few hours. Sometimes we might only get mains power for half of the time, 50% of the time. So then we had our own generator there, backup generator, and there was not an automatic circuit. I designed an automatic circuit, but it was fairly costly, and I'd have to make some unauthorized mods to the generator itself, so that idea got shelved. I still regret that to this day. I mean, that was probably 12 or 13 years ago, and I still think, I could have built that automatic switchover system. It would have been cool. Anyway, I digress. So it was right next to the SIGs, the signalers. They looked after all the communication stuff. So they had a big satellite dish. They made sure that we had internet, although it was relatively slow and patchy and only for very necessary things. Communications back to New Zealand, so the government could tell us what to do and stuff like that. So they had UPSs, but their UPSs were hopeless. So they would get, like, seriously about a minute of power out of the UPSs, and that was supplying all of the signals, all of the comms. And if it went down, if the power went off to any of their comms equipment, then they had to do all sorts of complicated stuff to get everything back up and running and all of that kind of stuff. So they really hated that. So they wanted to get the generator running immediately. As soon as that power went out, they wanted that generator running, so we could get changed over to generator supply before the UPSs run out. Now they considered that my job, that I should keep the generator running or get the generator running. If the power went out, then I should be the one to go and turn the generator on and switch it over, which I was happy to do. But of course, it's because they only had a minute of UPS supply. They wanted me to drop whatever I was doing, pinch off whatever I was doing, and run to the generator to get it running again. And I sort of thought, I'm not particularly interested in that. But we would have this ongoing argument back and forth. But of course, I always won that argument, because if I didn't get there in time, their equipment shut down. So it was their best interest to do that. And I used to take great joy in just slowly, when the power went off, just slowly walking around to where the generator was, and then you'd hear the generator start up and you'd hear people shouting, and I'd get round there and the SIGs would be running around going crazy, trying to get the generator started, and then they'd start swearing at me and going, we've got to get this running, what's going on? Which I just thought was the greatest joke in the world, because even though they thought it was my job to do that, they ended up doing it themselves. because otherwise it wouldn't get done in time. So I was just a bit of a dick about it, and I got my way in the end. So it became their job to start the generator, which was fun. Anyway, so yeah, little story about generators and UPSs. Okay, so a UPS contains a battery that kicks in when the device senses a loss of power. This allows the device, such as a manufacturing process computer, to save any data, initiate safety systems, and exit before the secondary power source, that's the battery in the UPS, runs out and before the generator starts. So we might have that lag time between mains and then battery of the UPS and the generator. When a power surge occurs, a UPS intercepts the surge so that it doesn't damage the device that it's connected to. So bear in mind here that the UPS or the device that's protected by the UPS is constantly fed via the UPS. So the mains is coming into the UPS, and then we have mains going out to our equipment. When the mains input is lost, then it switches over to its internal battery so that the supply continues. So that will also help us prevent surges and stuff. So we have a little diagram here. So there's our plug there. Power is coming in. Power just runs straight through to the output socket, and that's where we've got whatever we have is connected. That's our output socket, input socket. Simultaneously, when we've got normal mains running, power is going to the charger and to the battery. And there it is there. Beautiful. When then the on-off switch for the output is off. So that's open. So we have nothing running through from the battery to the output. When we lose voltage on the input, so now our main supply is lost, then we have nothing running through here, nothing running into the charger, we've got no mains. This switch automatically switches over. It would just usually run off a contactor. So we have, if we had a relay coil powered off here, then when the power's on, the relay coil was switched on, and that would hold that contact there. When the power switches off, that relay coil is de-energized, so the switch fails and drops out and falls into this position here. That's how we use. That's how we have that's the most basic level of automatic changeover switch. So when power's on, it's on, so it's this way. And when power goes off, the changeover switch falls the other direction. Really common for automatically switching power supplies, generator supplies, that kind of thing. Anyway, so the power goes off, that contact falls to that side. This, while also closed, it may that switch there may also be run off the same relay coil, so that automatically closes when the relay coil loses power, and then battery power will go through the inverter and through to our supply there. Easy, eh? Perfect. Every UPS converts incoming AC to DC through a rectifier and converts it back with an inverter. So it's converting the AC to DC to power the battery, to charge the battery, and then converting it back with an inverter because we want to, when we go into battery power, we need to change that battery power DC back to AC, put out to our machine. Batteries or flywheels store energy. So the flywheel, I've never come across a flywheel UPS, but I guess such a thing exists. A flywheel UPS would be a motor running a big wheel with a lot of weight behind it, and it would just turn it over, and then when the power turns off, that wheel, if you got a good balanced flywheel, big heavy flywheel, it can run for a while. So that flywheel would then keep running, even though it would just keep turning under its own steam, and then you could use that to power a motor, which would turn a generator rather, which would output some power. So that's the theory behind a flywheel UPS, although I've never seen one. I've never even heard of one. A bypass circuit routes power around the rectifier and inverter, running the load on the incoming supply or generator power, so that's our normal power. When power fails, the batteries drive the inverter, which continue to run the load. When power is restored, either from the supply or a generator, the rectifier delivers direct current into the inverter and simultaneously recharges the batteries. The inverter runs full time. Input is completely isolated from the output, and bypass is only used for maintenance, safety, or if there's an internal electronics failure. Okay, there we go. Applications: computers, data centers, telecommunications, alarm systems, process computers, programmable logic controllers, human-machine interfaces, surveillance systems. So any critical, usually like electronic or computer-based systems. So bear in mind again that we're unlikely to get a lot of power out of a UPS. Like the batteries aren't going to last forever, so they're not particularly useful for running big loads. They're not helpful if we need to continue to run the whole building or big machines or something like that. So that's why it's like computers, telecommunication systems, alarms, that sort of stuff. The advantages of an uninterruptible power supply. Just before I do that, first digit for your code. This is a 3-digit code for this test. The first digit will be 4. Number 4 will be your first digit of your code. Right, advantages of an uninterruptible power supply. Power consistency. A UPS will ensure there's no drop in power when there's a power outage. It also regulates power during spikes, surges and brownouts, ensuring your business runs smoothly. So that means we're not going to see, like I said, with a generator, when the power goes out, and then we turn the generator on, and then we can get power back onto our stuff, which at the very fastest, even with an automatic changeover switch and the generator starting automatically, it's going to take 5 to 10 seconds. So that 5 to 10 seconds will have no power. So our computers will switch off. Any data will be lost, or any unsafe data will be lost. So UPS can bridge that gap. Power continuity. There's no disruption to your power supply when there is an outage. It ensures no important machines lose power before you can start up your backup generators. Exactly what I just said. Prevents significant loss of data. Or UPS ensures that no electrical devices stop running when there's an outage. So all of your data will be protected, and you have time to either power down important services or connect your backup generators to ensure no data is lost. It protects machines and equipment. In a similar way to data protection, a UPS ensures that no damage is done to sensitive machinery. Gives you time to correctly power down or turn on backup generators. So that's another advantage, right? Is that even if we don't have a backup generator or whatever, and we're not going to be able to run on our UPS long enough until the supply comes back on, at least it gives us the time to shut everything down correctly rather than just dies because the power's gone out. And reduce noise. Unlike a backup generator, a UPS has almost no noise output. The noise output would be like there'd be a cooling fan or something. And UPS typically looks like a computer, like a PC hard drive box. So it'll have a power output, a little fan on it, and that's about it. So it will not disrupt your day-to-day activities, and it can be installed almost anywhere. Unlike a generator. So a generator obviously is going to be really noisy, and you can't put it in sensitive places. I can tell you from working in the fire industry that you have diesel driven pumps to pump sprinkler systems, particularly in tall buildings where you need to get water to the top floors. So we would do it's required by law to do a weekly test on the diesel engine. So all that means is we would go and run it for 15 minutes. It's literally the law says you must run that for 15 minutes. So it's similar. It's not a generator, but a similar sort of thing, just a diesel engine running a pump. And you'd usually have those in the basement of multi-story buildings. As I said, they're a boost pump, so that if the sprinkler system were to go off, those pumps will help push water all the way to the top of the building. So we would go and do those tests, and depending on the buildings, we would go, if it was a commercial building, I would have my guys going there between 6 and 7 in the morning. So like the big buildings in central Auckland, big Spark exchanges, Chorus buildings, big office buildings, that kind of thing, we would do those between 6 and 7 in the morning. And if it was a domestic building, like a domestic apartment building where people lived, so again, these would be high-rise apartment type buildings, we would do those somewhere like 10, 11 in the morning. The idea there was if at a commercial building, if we did it before 7, then there wouldn't be people there working. And in a apartment building, if we did it like 10, 11, then we wouldn't have people sleeping or, normal stuff. It's an ideal time that, okay, it's going to be noisy. And even then, even if we stuck to those times, we would still get complaints. Even though we would run it only for 15 minutes and everyone knew it had to be done, it was a law, still get complaints all the time. Why does the guy have to run the diesel pump? Oh, I was working and it was really loud. It's like the generator's in the basement and you're working on the 14th floor. Like, seriously, stop moaning. We'd get complaints about the exhaust because it would have an exhaust that would run, had to run outside, but then it would, smoke would go up the side of the building and it might come in the windows and people would whine about that. I was working and then the smoke came in the window and it smelled bad and I got a headache. Ridiculous. So you can imagine, the reason I say that, you can imagine that if you've got a backup generator, that as soon as that thing starts, that's going to start causing people problems. Even if it's placed away from the building, people are going to hear it, they're going to get pissed off. So a UPS doesn't make any noise. That's the point of that little story. The disadvantages of a UPS: startup costs can be higher than a regular backup generator depending on the infrastructure you have in place already and what electrical devices or areas you need to power. So I guess the point there is that like a UPS will not in most cases be more expensive than a generator, but a generator you would have in place to usually power the whole building, whereas a UPS is going to power like one computer or one room with computers in it or something. But if you wanted to do the same job, like if you wanted to power the whole building or the whole house with UPSs, like you would with the generator, that's probably going to cost you a fortune. You're going to need a lot of UPS capacity. We need very high quality batteries. To ensure your UPS is at optimum performance, you will need to ensure that it has high quality batteries that can add to the cost of the installation. And the batteries will need maintaining or replacing, which could be anywhere between 3 and 10 years, depending on the battery. They won't last forever, even if you don't use them. Just sit there and they sit on charge for a couple of years. They are going to wear out. The performance can be affected by the environment. So in hot environments, the batteries wear out quicker than in cool ones, and that means that the area that you install the UPS will affect its performance and longevity. Requires expert installation. To ensure your UPS is correctly set up, you will require an expert to install it into your current system. If incorrectly installed, it may not work or potentially damage your existing power system. I dispute that a little bit. I mean, generally a UPS will have a power rating. It has an input plug and an output plug, and as long as whatever you plug into it does not exceed the UPS power rating, and you plug power into the input and your output on the output, then you can't really screw that up. I don't know. Energy use. A UPS system does require an energy input whilst it's not fully functional to ensure the batteries are fully charged and ready for power outage. It also requires a comms input, so it's able to make users aware that there's a power outage, which means that it's going to be constantly drawing a small amount of power regardless of whether you're using it or not. So that's a disadvantage because it's going to suck a little bit of power. Right, so moving on to standby generators. Let's just go back here. Now there's one thing here, like I said at the very start, that this topic to me is about awareness of these different types of power supplies for safety reasons. Now, we don't actually talk about the safety reasons in this slideshow at all, or even in the test or anything. But to me, when you look at all of those different types of power supplies, why do I want you to know about that? I want you to know about that because it's a safety issue. So what I'll say about a UPS is if you go into a building and it has a UPS connected to an outlet or a supply or something, what you need to be aware of is that when you unplug that UPS or you kill power to the UPS, it will continue to provide output to whatever it's supposed to be providing output to. The UPS doesn't know when you go into a building and isolate a circuit that that's not a power out. It's not a power cut, right? The UPS doesn't know. All the UPS knows is the power went off. So the UPS's job is what? When the power goes off, I supply power. So you need to, it's one of these situations where you really need to be very, very switched on with your testing, because the outlets out there may be outlets that remain live even though you've turned the power off because they are supplied by the UPS. Right, let's move on. Standby generator. Standby generator is a backup electrical system that operates automatically. Within seconds of a power outage, an automatic transfer switch senses the power loss, commands the generator to start, and then transfers the electrical load to the generator. The standby generator begins supplying power to the circuits. After supply power returns, the automatic transfer switch transfers the electrical load back to the supply and signals the standby generator to shut off. Then returns to standby mode where it awaits the next outage. To ensure a proper response to an outage, a standby generator usually runs weekly self-tests. Most units run on diesel, natural gas, petrol, or liquid propane gas. Okay, so I have a reasonable amount of experience with standby generators and generators in general. It was one of the my primary things that we did in the army as electricians. As you can imagine, a lot of the electrical side of my job when I was in the military is getting, distributing and using power in areas where you have no power. So you're out in the bush, hiding from the enemy, and any power that we use has to be done by ourselves. So it's generally generator supplied. And I talked about my little story about East Timor earlier. It was a really important and very common part of my role, particularly overseas, is to look after the generators, make sure they're running, and so forth. So a few points here that my experience differs slightly. An automatic changeover on the generator, that is certainly a thing that exists. A lot of backup generators won't have that. A lot of backup generators will require a human person to go and operate it. That's just a little, it's just a semantic point, really. How does that work? Well, it's kind of like what I was saying before with the UPS, right? So if we would have a couple of relays or contactors. So we have a contactor. If you can imagine a contactor that has two inputs, or no, let's say two contactors. One's got main supply coming in, one's got the generator supply coming in. On the outputs, those two things are linked together, and so we have one output and that goes to the building. The contactor for the main supply is held on by the main supply. The contactor for the generator is held off by the main supply. So one would be a normally open, one would be a normally closed contact. When the main supply turns off, then the contactor for the generator supply turns on, and the contactor for the main supply turns off. When main supply comes back on, it's automatically going to open the contactor for the generator supply, close the contactor for the main supply. So that's how that would work. You might have a changeover contactor, but let's say two contactors just to keep it simpler. This is not part of the test. It's just, I think, it's interesting and important to understand about how does that work. You'll have another little circuit that's going to go to the generator and do things like automatically turn it off, switch the load over, all of that kind of stuff. But yeah, usually just a changeover contactor system that's going to turn one off, one on. Neat. That's the kind of thing that I was trying to design in Timor to try and actually, the automatic changeover of loads is pretty easy. Like I said, you just have two contactors, one's normally closed, one's normally open. The technical bit is getting the right signals to the generator to tell it to turn on, and then after it's turned on, then there has to be a time delay before it switches the power outputs on, because you don't want the power out. You don't want the generator to be trying to supply power while it's starting. It needs to start up first. So you need like a 10 to 20 second power or 10 to 20 second delay from the time the generator, you send the signal to the generator to start, and then send the signal to the generator to turn the power output on. And then you also would need some sort of safety circuit in there to work out if you sent the power signal to the generator or the turn on signal to the generator, but it didn't start for whatever reason, just like sometimes you turn your car on and it doesn't start, maybe a flat battery or something. So if it didn't start, then I don't want the signal to be sent to turn the power output on. So I designed that. I figured it all out on paper, and just never put it into practice because it would have been expensive, and really this is a very military thing. Like I said, about the first sentence on this here says standby generator has an automatic transfer switch, blah blah blah. That might be common in the civilian world. In the military, they would never have an automatic system where you could just use the power of a soldier, because it costs nothing. So, or things like me building an automatic changeover system for the generator, when I go to the boss and say, hey, I'm going to do this, it's going to cost like $3,000, and he'll say, well, what does it save me? And I said, well, then it means that nobody has to go and turn it on. And he'd go, but I can just get you to go and turn it on. That costs me nothing. Your time means zero to me. You're just a cog in the machine. You're just a pawn. So why would I spend $3,000 to save the 10 minutes that it takes you to go and do that? I'll just make you go and do it. So that was the other reason I never got it done, is because nobody wanted to spend the money. And realistically, it wasn't really needed. It was just something fun that I wanted to do. You get very bored when you're overseas. Anyway, okay, operation. Right, so we got an automatic transfer switch here. We're imagining a world where everyone has automatic transfer switches instead of just young men in green clothes who are going to do their bidding. So first thing that happens is the power goes out. Standby generator detects a problem, so that's usually that contactor switching over. So one side falls out, one side switches on. The generator then turns on automatically. Electricity is restored. Life is normal. Lovely. Components. The main components of a generator are engine, alternator, fuel system, voltage regulators, cooling and exhaust system, lubrication system, battery charger, control panel, main assembly. Look, it's like a truck engine usually. In fact, most generators run literally off truck engines. The generator manufacturers buy engines from trucks and put them into generators. Probably the biggest, most interesting thing there is your voltage regulator. That's where things get a bit different, right? A truck will have a fuel system, a lubrication, cooling and exhaust system, and in most cases it comes straight across from the truck, or in a lot of cases. Alternator, yeah, so your vehicles will have an alternator in them. Alternator is going to be different because it's going to be our main power output. So it's going to be a fairly intense alternator. However, it's not like the alternator doesn't exist, but the voltage regulator, so what that's doing is sensing the voltage and then changing the engine speed constantly to try and keep that voltage at the same level, which is a very, very technical process happening inside that generator. You can imagine every time, if I've got a generator running a household, a building, a military camp, whatever, every time somebody switches something on or off, that's going to change the load on my generator and therefore change the load on the engine. So if the engine is pumping a certain amount of fuel into the cylinders to maintain a specific speed, and then I turn something off, then it's like or if I turn something on, it's like hitting a hill. The engine has to work a bit harder. It's going to require some more fuel to maintain the same speed. So the voltage regulator, so it'll start to slow down when I put more load on it. And so the voltage regulator will sense that speed changing, or sense the voltage changing, and it will instruct the engine to supply more fuel until the voltage gets to a certain level, and then the voltage regulator is going to say, okay, stay there. And the problems we used to get with military generators are always voltage regulators are the biggest problem, because it didn't take much for it to go crazy and haywire. There's in fact a little spring linkage between the governor. The governor is the mechanical component that the voltage regulator is talking to. There's a little spring inside the governor that when it got stretched, it would react too slowly. So what would happen is the voltage regulator is telling the governor put more fuel in. The governor would say okay, and then it would move, and this, because the spring wasn't responding quickly enough, the voltage regulator would say, you still haven't given me more fuel, I need more fuel. So the governor would say okay, and then by the time the governor caught up with what the voltage regulator was telling it to do, now it's running too fast, and so the voltage regulator would say, stop, give less fuel, and so it would cut it back. And of course the spring was stretched so it wouldn't react fast enough, because the voltage regulator is sensing and sending signals really fast, like multiple times per second. So if the governor's not responding fast enough, then it hunts, because you tell it to speed up, and by the time it reacts, it's going too fast. So you tell it to slow down, and by the time it reacts, it's going too slow. So you get the engine speed, and you'll hear it, and it'll go, vroom, vroom, vroom. That's called hunting. That's because there's something wrong with that voltage regulator and or the governor. And in particular on the New Zealand Army generators, which they probably still have in service, there was a spring in there that would wear out, and it would just cause the reaction of the governor to be a little bit too slow, and you get this hunting. It's the most ridiculous thing in the world. The engine would just surge up and down, and your voltage output would be all over the place. So voltage regulators, very deep and interesting topic, I guess, in general. Certainly for me, probably it's well beyond the scope of what we're talking about. Never mind. The necessity of what we're doing has never stopped me from going and telling stupid stories. Alright, so the energy, the components, the engine is the source of the input mechanical energy to the generator. We know about this. The size of the engine is directly proportional to the maximum power output that the generator can supply. Well, that makes sense, right? If I want more power, I need a bigger engine. The alternator is part of the generator that produces the electrical output from the mechanical input supplied by the engine. It contains an assembly of stationary and moving parts encased in a housing. The parts work together to cause relative movement between the magnetic and electric fields, which in turn generates electricity. A fuel tank usually has sufficient capacity to keep the generator operational for 6 to 8 hours on average. In the case of a tiny generator unit, the fuel tank is part of the generator skid base or is mounted on top of the generator frame. Voltage regulator, the conversion of AC voltage to DC current. Voltage regulator takes up a little portion of the generator's output of AC voltage and converts it into a DC current. The voltage regulator feeds this DC current to a set of secondary windings in the stator known as the exciter windings. It does lots more than that. The exhaust fumes emitted by a generator are like exhaust from any other diesel or gasoline engine, contain highly poisonous chemicals that are required to properly managed by an exhaust system, particularly if that generator is inside a building, like in the basement of a high-rise or something. Since the generator comprises moving parts in its engine, it requires lubrication for durability and smooth operations over a long time frame. The generator's engine is oiled by oil stored in a pump. Start function: the generator is battery operated, just like a car, starter motor. The battery charger keeps the generator battery charged by supplying it with an exact voltage. The control panel is the user interface of the generator and contains provisions for electrical outlets and controls. All generators, portable or stationary, have customized housing that can provide a structural base support. The frame also allows for the generator to be earthed for safety. Applications: critical safety systems such as elevators in high-rise buildings, fire protection systems, standby and emergency lighting, medical and life support systems, critical plant safety systems. Residential standby generators can be there for HVAC, so heating, ventilation, air conditioning, so your aircon. Security systems, appliances like fridges or stoves, water heaters and lighting. Standby generators not that common in a residential building. Hospitals and stuff like that will have standby generators. The biggest thing about a generator, let's have a look, advantages and disadvantages. So advantages: fast automatic delivery of emergency power after power lines fail. Allows you to maintain comfort level at home or work during emergencies. Ensures that you may keep adequate food supply and water during extended power outages. Allows you to continue running your company's operations when power fails. Units conduct self-diagnosis every week and display alerts about status. Fuel autonomy to last several days or weeks of operation. Allows you to normally operate your home or business, including use of internet, heating, air conditioning. That can be sized to turn your entire house or building, or just a critical portion that's most important. Okay, nice advantages there. Automatically disconnect your house or building from the power lines when power fails, isolating you from the power during a power failure. It protects electronic devices from violent power surges, spikes, or brownouts, so when the power comes back on, you're not going to be getting all sorts of weird stuff. As it says there, the power returns. Generator does not transfer to the power until the voltage has stabilized, protecting from dangerous surges and voltage fluctuation when power is first turned on. They are permanently installed. No need to run extension cords and set up your unit in the middle of a storm or other natural disasters. Safe operation during storms or man-made disasters. No need to improvise a backup energy solution during an actual emergency. Afford you peace of mind by ensuring that your loved ones and the things important to you are well protected during times of emergencies. Allow you to remain home and in familiar surroundings during a storm or extended power outage, rather than fleeing to a hotel which may not be available as they too may be out of power or full. Well, look, that reads like the sales brochure for somebody who wants to sell me a generator. So whilst all of those things are true, let's have a think about the cost of putting in a generator system, and then think about the amount of times. Think about the amount of times in the last 5 years where you would have used a generator system had you had one available, and what did you do instead? And well, we're all still alive, so they're obviously not that necessary. Yeah. I'm skeptical, very skeptical of a lot of what that says. Disadvantages: standby generators are more expensive to buy and to install. These units require longer time for installation. Permitting process may delay installation. Installation requires planning. They require yearly maintenance, which adds to your budget. They're permanently installed, which makes it difficult to take with you if you move, and they need to be in well-ventilated area to avoid carbon monoxide buildup. It's in the case of petrol and diesel. Actually, I those again are all true, but what I will say about that is I think the biggest disadvantage of a standby generator is fuel. So your fuel won't last forever. In fact, your fuel will probably last 6 months. So the question is, what are you going to do? You want that generator, again, if you think about how many times in the last 5 years you would have needed a generator or would have used a generator should you had one available, and then how long is it between usages and what happens to the fuel in the meantime. If you do need it and it is a genuine emergency, you don't want to have to go and get fuel for it. At the same time, if you leave that fuel in there for more than 6 months, then your generator's probably not going to run anyway. So the question is, how often do you have to put fuel in it, change the fuel in it, and what is that going to cost you? In the case of large backup generators like running hospitals and stuff like that, they might be looking at days or even weeks of no fuel delivery, and therefore have the ability to store enough fuel to run the generator for that period of time, which will be run into the thousands of litres. Are you going to change thousands of litres of fuel every 6 months? If you have 20,000 litres of fuel, that's about of diesel, that's like $30,000 worth of diesel that you're going to swap out every 6 months. Nobody wants to pay for that. Just this seems like there'll be a hell of a lot of other options that you could avail yourself of that would cost less than $30,000 every 6 months. All right, that is it for part 1. So UPSs and generators. The next part, video part 2, will be switch mode power supply. So these little electronic jobbies. This is quite a long topic, unfortunately. So how long have I gone so far? 40 minutes. Wow. I'm going to do 3 videos. I'll try and make the next 2 shorter. See you on the other side.